Welcome back to our series on SafeML. Last time I talked a bit about the concepts involved in SafeML and the elements that it uses to represent safety information in a system model. Today I'm going to be taking you through the drawing of a single SafeML diagram to show how you produce a SafeML model. The example I'm going to be producing today is based on a robot wheelchair. The purpose of this robot wheelchair is to safely convey a user around town to the destinations they want to go automatically without them having to provide too much input into controlling it. And so there are many risks involved in using this system. We have hazards such as pedestrians and harms such as injuring pedestrians or the rider. We also have several harm contexts involved or hazardous situations, and these include the fact that the wheelchair is going to be used in the same area as pedestrians and therefore may come close to them, producing hazardous situations. We include several safety features in our robot wheelchair. Today I'm going to be talking a bit about the safety feature that is the emergency stop, and also talk about how the wheelchair knows when to activate its emergency stop automatically, which is our monitoring system. So this is the diagram that I'm going to be building today. It's quite large, involving several elements, but quite concisely describes one hazardous situation and the safety features involved in protecting against it. So I'll start by producing a hazard. This hazard in our case is going to be pedestrians, because these are always going to be walking around the wheelchair, and our safety analysis has determined that there could be a hazard to the wheelchairs, the safety of the wheelchair's rider or the safety of the pedestrians themselves. And you'll notice that I've linked this to the footpath, which is a part of the external environment around the wheelchair. I've denoted this element in brown to indicate that it's part of the system model, connected by the derived hazard relationship to show us that this is where the hazard comes from in our safety analysis. Next, I'm modelling the relevant harm and connecting it to the hazard. So the harm is injury to a person, which may be the pedestrian or maybe the rider. And this is just modelled simply by an element which we include on the diagram. We then connect it to the hazard that may cause it using the harm context element, which you can see here. So in this case, our hazardous situation is the user driving the wheelchair into a pedestrian, which is somewhat malicious but has been known to occur. In this case, the activity user controlling the motion of a joystick is what gives rise to this hazardous situation. So if we give the control of the wheelchair to the user, they may cause this hazardous situation to arise and therefore cause harm to occur. You can see in this case that I've also tagged the harm context element with several important pieces of information for my safety analysis, such as the probability of harm occurring, the probability of the hazardous situation occurring, and the severity of harm that may be caused. These tags are very useful when you're looking at the information later on in order to determine the priority of different hazardous situations for safety features. So on the next slide, I've added a safety feature to my system. In this case, it is the green element on the right, the active defense element. And this is an emergency stop. And this is connected to the harm context that it may cause by the defense result association class. And this class describes the result of the defense being applied. So it again contains the same tags as my harm context, but with new values to indicate what will happen to them when the defense is active. So in this case, if I activate my emergency stop, I will reduce the probability of harm and reduce the probability of occurrence being caused, of the hazardous situation being caused. However, this is an active defense, and so at some point in my model, I'm going to need to add a monitoring system to make sure that this defense gets activated when it should be. But first, I need to make sure this safety element does something to the system model. In SafeML, this is by adding a requirement that's linked to the defense. So this requirement, which is related to the defense that it comes from, is called a safety requirement, and I've highlighted it in red to distinguish it from my other system requirements in order to indicate that this is related to safety. And this requirement is treated like all other requirements in SysML because it has blocks that implement it and test cases that verify that it exists. So next I'm going to look at how I'm going to activate my emergency stop. And to do this, I need to have a monitoring feature in my system. This monitoring feature is represented by the context detector element, which I've added to the diagram in the bottom here, represented in blue. And what this does is it's an obstacle detector, so it detects when obstacles, in this case pedestrians, become too close to the wheelchair. And so that is what we define as our hazardous situation. As with the defences, context detectors need to be implemented by the system, and so therefore we again need a safety requirement to be added to our model. In this case, we have the requirement for detecting pedestrians, which is related to the context detector that it is derived from. And again, like any other system requirement, it is implemented by blocks and tested by test cases. So here we have the full diagram. It describes quite succinctly our entire hazardous situation and the safety features related to it. So in this case we have the hazardous situation of a user driving the wheelchair into a pedestrian, and we can see quite clearly that there is a monitoring system looking for the situation, and there is an emergency stop defense that is trying to protect against any injury being caused when the situation arises. And one thing I want to point out here is that on the previous slide, all the elements that were in brown were the system model. They were not part of SafeML. They were not directly part of the safety information, but they're related to it. And this shows how parts of the system model are integrated tightly with the safety information, allowing you to improve the traceability of your safety information throughout the system model and the system design itself.